And now I would like to get on to our guest speaker. Antti is going to be presenting about pediatric health data spaces. Antti, if you're ready to share, looking forward to it.
Yes, I can do it, definitely. And I do need to update that picture. I have much more hair everywhere right now. Right, hey, wonderful, great to see everybody. And a lot of familiar faces and names. Most of you was really excited to show what I've been working on for the past year and a half. And just share a lot of the knowledge and learnings that we've got from this project, and hopefully it inspires you. And if you want to get deeper into these topics, I'm going a little bit quite high level because there's a lot of magic and a lot of mystery behind the high level stuff, a lot of details. So we can only glimpse the surface for now. But yeah, so I'm really happy to talk about this in more depth, in more detail, with anybody who wants to learn more. So we're talking about the pediatric health data space. First, I want to go over a little bit what's the need for this, what is this project I'm working on. Then we're going to go into the details of why we need this, what's the actual problem we're solving, and why is this kind of data space or digital ecosystem a good alternative here. And we're also going to go deeper into what the design is, so how we're solving things, what the trust layers are set up. I hope that I can be quick in the beginning so we can spend more time in the more interesting bits. But I think it's very interesting overall. So if you don't know me, I'm Antti Kettunen from Finland. I've been working in trust over, well, not working, but active in trust over IP from almost its inception. And right now, I'm in this meeting. I'm representing FEM's EU project. I do work, or have been working for the past years, quite extensively in digital identity as well as digital ecosystems. Especially the EU DI wallet has been something I've been working on for the past couple of years, quite a bit, and this pediatric health data space. Okay, but onwards. So FEMS is essentially a project funded by European Union and UK Research and Innovation, and the need for this comes from data sharing in the pediatric space. So the need essentially comes from the pediatric and rare diseases have very small numbers of these patients per country. And there's constant need for newer therapies for these kind of rare diseases. A lot more engagement is needed with medtechs, with innovation ecosystems, and in general in benchmarking between hospitals as well. But also many countries only have one or two hospitals in the pediatric space. So just the sharing of information is tremendously much needed, especially in this space of pediatrics and rare diseases. FEMS is, as I said, an EU-funded program, UKRF-funded program. We have 14 partners with almost half of it, they're hospitals from different European countries. We started about a year and a half ago. We still have another year and a half to go. And what we're doing essentially is we're designing a pediatric health data space. The FEMS acronym is, I don't have it here. I don't even remember what it is, but it's you can have a look at it at fems.eu website. The point is that we're building and designing this pediatric health data space. So essentially, the secondary use of healthcare data in general holds a lot of untapped value potential, even outside of the rare diseases and pediatric space. And there's a lot of challenges in accessing useful and frequent clinical operative benchmarking data. And that's especially for hospitals who want to really focus on developing their care and their treatment plans. And just the general need to speed up the permit processes and the data processing times while lowering the cost of operations. So this is really critical, that the current way that they're doing it is manual effort. A lot of it's a manual effort, really slow, takes months at a time to actually get data permits for secondary use. And that's just, we're not in a good space in general in this. There's a lot of challenges in the current solutions as well. There are some solutions that try to tackle this, but they don't necessarily cover the regulatory requirements, especially in Europe. The European Health Data Space Regulation was just adopted, and it defines a lot of new things for secondary use of data. Finland especially is has one of the most strictest legal systems regarding secondary use of data. We are currently updating that as well, but there's, especially in Europe, well, we know how to regulate, but in this area, we're very careful as well as to how healthcare data can and should be used. There's a lot of unharmonization. Everybody has their own processes. There's no business models essentially for this, as many and most of the hospitals in this space are public hospitals, so they're not very business minded. And just the privacy, data interoperability causes challenges. Scalability is always a big challenge when it comes to this, and just in general, everything in healthcare has high operating costs. So a lot of things to cover and to try to solve. So the PHDS really tries to simplify access to healthcare data for benchmarking and research processes. And this tries to solve the complexity of secondary use in general. So as I said, this is really focused first on the rare diseases research, and also but other cases where international collaboration around secondary data is definitely something that could be used for in future as well. And what PhDs enables is that hospitals can engage in benchmarking between other hospitals and also do cross-border research projects with commercial and academic entities. And it is really designed ground up. So we started from scratch on thinking how this whole industry, what does it need? And to actually advance use, make everything really a lot faster, make the business models work, make it scalable while ensuring the security and privacy. And we're using federated data processing for that. I'm going to explain a little bit how that works in here. First, I want to explain what is the current state and how it currently works and how we see that we need to change it towards. So currently, when you want to use secondary data, secondary patient data, so in this case, secondary data use means that you use it for research. It's after you've gone through the treatment and you need to use that for different types of research. So it's the secondary part of that data use, not for treatment purposes in this case. So at least in Europe, I'm not exactly sure how it works in US or other continents, but at least in Europe, the general mechanism looks like this. Is that data users or researchers, they created bilateral agreements with a data controller. A data controller in this case is a hospital. And the data controller provides an isolated, secure processing environment to those researchers. So it's essentially, they create a completely airtight locked-in system where you cannot copy information out, you cannot bring anything in, it's completely locked out. So within that space, you're allowed to do some kind of an analytics against the data sets that you request the data permit for. And when you want to take out some of that data, then you need to work with the hospital employees manually, and they review what you're actually getting from that information. And then they sanitize it, they anonymize it, they want to make sure that nothing disallowed is actually getting out of that tight space. So very controlled. You cannot get really much more controlled environment than this. And you can imagine to try to scale this in the rare disease perspective. So you can imagine that this will not work when you need to have access to multiple data controllers and even in multiple countries. So here you just see three different data platforms or data controllers you would want to access. But in practice, you would need to probably have more, 5, 6, 10. And imagine that in this case, the data user, the researcher, would need to handle all of these data permits with each country, with each data controller, access the data in those tightly controlled environments, try to export the data in some form, and these can be very unharmonized data formats as well. Try to concatenate, try to aggregate that and match those together and then work with it. And because everybody has their own processes, it can, for just one data permit, it can take months, literally months to go through it. And it's really, really slow. And the feedback loops are long. So this model has a lot of manual work. and it requires manual work from all parties. It's not easily scalable to multiple data controllers. So it really, the current way of doing things does not work. So, so what would be the solution? Is to approach it from the digital ecosystem perspective. And from this perspective, we would form an ecosystem where we define the rules, we define the agreement structures, the contracts, the data permit applications are harmonized. We generally harmonize the process of executing the application process and everything we can. We make the whole process end-to-end faster and easier. We want to achieve scalability, but to do that in the scenario where we have multiple countries, multiple data controllers from different legislative areas, is that we use a new role. We created a new role in this project called the workspace provider. So we actually created a new type of, we understood the value chain that initially was built, and we realized that this doesn't work. We need to scale this. And the way we scale it is to introduce that workspace provider. And that is a service provider that provides a platform for the data users, the researchers, for managing their project information, for managing different kinds of data exchange requirements and the different processes with the data controllers. So the workspace becomes, it's not a space for making analytics. It's more, so it's not a tightly controlled space. It's a space that abstracts a lot of the manual effort currently done and creates the capabilities to automate that and really scale that with multiple data controllers. And it also plays a pivotal role for the contractual and governance rules that need to be in place for this to work. So some of the features of the pediatric health data space. So in this big picture, you can see we have the data users on the left side, the project workspace, the workspace provider next to it. On the right side, we have hospitals or the data controllers. They can be other than hospitals as well, but initially we do see that it's mainly hospitals that would be providing the data. We have some features I'm going to go through, and they're based on the identity trust model, the data exchange layers, and different kinds of data discovery systems. I see, Eric, your hand up. You want to ask a question?
Well, the question is, do you want questions now or at the end? Are you happy to be interrupted?
Generally,
Or-
I think we can take questions while we go, so no problems.
Okay, so the question here would be, if you will talk about it later, the identity model. In the trust over IP ecosystem, we talk about the identities are verifiable, and then the data is also verifiable. Will you talk about that a little bit later? Or no?
Yeah, I have a separate slide for the trust model in general. Right. So just to get your idea what the features are here. First, when a data user researcher wants to run this, wants to get access to data, run their analytics, they need to find out the data availability. So the researchers will discover available data in the data space by using consolidated OMOP metadata. So that's a general common data model that is quite popular nowadays. So it's a structured, well-defined common data model that can be combined with different vocabularies that then allows to create a very well-defined, structured set of healthcare data. And that availability is reached from all the data controllers in the network. Once the availability of the data is understood, that which data controllers actually hold the data they're interested in, then the data users use the workspace to create the data permit application. So the data permit application is obviously one of the things that we harmonize here. And we do that, we use the data permit application and the process and systems here to do a concurrent application process with all the selected data controllers that are participating within this research project. Once that data permit application process is run and the data permits are received, then the federated data processing can happen. And so the data users essentially provide their analytics algorithm that also is being vetted separately or also machine learning algorithm. That machine learning is another thing that we're exploring also in the FEMS project. And that is being executed by the data controllers using what we have federated nodes. So I'm going to briefly explain that later as well. And then once the analytics are run, the results are being released securely by each data controller using automated manual measures, really depending on how the hospital policies, how they want to go through the results release. So this is sort of the very, very, very high level of what happens, what this is about. So these 4 primary stages. So let's step back to the governance. So I know you all want to see that. So the governance really is based on having a governance model that is operated by a neutral governance entity. So you can see here that we have ecosystem governance entity. In our use case, what we are right now aiming for, that this governance entity is the European Children's Hospital Organization. It's not being fully decided whether that is by the ECHO board, but that's something that we aim for. On the right side, we have data controllers, i.e. the hospitals who hold the data and provide access to the data. On the left side, we have the workspace provider, and then the data users work with the workspace provider. The ecosystem is founded by members, and the founding members in this case will be hospitals. And hospitals will because the ecosystem governance entity is also the European Children's Hospitals Organization, it makes sense that some of the members of that association also will be the founding members of the PHDS. So the founding members and the future members will agree to the founding agreements and also create an ecosystem governance entity governance model, which defines how the PHDS governance entity is being run. And within this ecosystem with the members, then they are responsible together for defining the actual playbooks or rule books, how we use it. And we have a few different levels of rule books. And these rule books essentially define the contractual requirements, the different kinds of role-specific agreements that are being agreed to, and different kinds of technical specifications and other types of rules that you could imagine this kind of ecosystem having. The data user here, the researchers, agreed to terms of use with the workspace provider, and the terms of use are partially defined in the common rules, but partially they obviously can be workspace providers' owns. But you can see here that the trust will be based on contractual agreements. So the trust is how data controllers can trust that the data user will be a good behaving party, is that you can see that we have agreements that will be signed by all parties. Workspace providers will have their own rules and agreements that they agree on, and they also will have that liability toward the data controllers and the rest of the ecosystem to make sure that whatever happens, that they are doing everything they can, and that the data users that are their customers are actually behaving properly. So really, it's something that we are really want to make sure that this is a strong governance model, a strong foundation based on contractual models. So all the ecosystem members will be either full members or associated members. Workspace providers are associated members, and most of the data control, and actually some other data controllers also can be associated members. So all members can participate in the governance development, for example, rulebook development, but decisions are made by the full ecosystem members. And that's something that is really, because a lot of the data controllers, they're public parties, they're public sector parties who have a legal standard, legal requirement as well as to what they need to protect, in this case, the data. And yeah, rulebooks define the commonly agreed requirements and policies and refer to any of the implementation specifications as well. Okay, I can see a hand up again.
Yeah, there's a lot of different countries that are involved in this. So what was it difficult for them to say where is the rule of law? Is it is it UK law? Is it European law? Is it was that difficult for everybody to agree to the
Yeah.
underlying?
So right now, yeah, a very good question. And what should be made clear is that at this stage in FEMS, we're still a research and development project.
Mm,
So it's not yet a production environment.
right.
And after, or actually during and after the FEMS project, during the next couple of years, we are aiming to see the next level, which is going toward the production level, where these will be in fact defined. In Europe, like I mentioned earlier, the EHDS will set a lot of the baselines because that is already commonly will be agreed. I believe the UK will be aligning with that as well. And so that's something the ECHO Association already provides a firm basis for the collaboration, which is a really big thing here, which makes this possible, is that there's already a good ground of collaboration because there's already 2 years of collaborative history. And yeah, and also what is to be noted, if you know anything about the EHDS work, so in European Health Data Space Regulation, there is one clause that states that this regulation essentially doesn't apply if you have a contractual ecosystem which includes public and private property. So this will be aligned. This is very much aligned with the EHDS regulation, but it's not being governed fully by it. So that's a very, I think, good point and important point.
Thank you.
But yeah, but the same model we do see that could be replicated to other areas as well. So the governance agreements and the legal system, it needs to be modified to that area where that is being used.
Okay.
But we see that data controllers and providers from other continents as well and legal jurisdictions could join. So we don't see a problem in that.
I think Annika
Sorry,
had her hand.
Antti. Yeah, I can't find for some reason the virtual hand, so I'm using my real one. Sorry. I was just wondering if I may ask that when designing this architecture, what were the most difficult bits that sparked the most debate? Or was it easy? Like, this is obvious.
Yes. Yeah, some parts were surprisingly easy, but the most difficult part was to understand that what is the purpose of the workspace provider? Because they were so set on the understanding they control everything. So the difficult bit was for them to understand that, hey, we don't need to control everything if the governance is in place and contracts are in place and liabilities are set. So some parts of those can be transferred to other parties, and that was the big thing. And to understand that that previously the hospitals had direct control and direct relationship with the researcher, and in this model they don't have that. I wish, but they will have all the necessary capabilities to verify who's the data control, who's the data user, etc. So, okay, hopefully that answered. So, yeah, that was a very interesting to find that. Okay, that you have a hard time grasping the fact that this is decentralized. And was a very new thing. But yeah, it's very when they got it, they realized, hey, this actually could work. All right. Right. Okay. But then I think I teased to Drummond earlier that there's one controversial bit I'm going to share that not everybody necessarily agrees with. Now, this is it. So regarding the data exchange and shared services, which are really important bits. So essentially how we exchange data between the project workspace and the hospitals, and how do we scale this? So some requirements, so some of the requirements we identified for the data exchange. There's a little bit background on it. So we needed to have one-to-many data exchange, meaning that we have one workspace where there's a research project. It needed to communicate with X number of hospitals. It could be 10, it could be 50, it could be any number, essentially. So we need to have one-to-end relationship which scales. We needed to have some kind of collaborative review process on content like data permit. So you can imagine a data permit, even if it's harmonized, it will have some specific fields that will be by nature of the legal system and differences of the regulatory space that some hospitals, some nations will have their own requirements, their own fields. So you will have this kind of a combination of some parts being harmonized at the same, some parts, small pieces are data controller specific. So yeah, you also need to have collaborative review, that there's a feedback loop that in your permit, we want to know more, please write this a little bit more on this, and we don't understand what you mean by that. So that needs to be a easily doable and easily commentable. Then we needed to be able to also reference directly the approved versions, things like the data permits or code or algorithms that are being developed, so direct references. And also traceability in what has been done, who has made those changes, if there's any changes, and what they're based on. And also, obviously, processes. We need to the process state needs to be managed between each hospital, the workspace and hospital. And also, a key thing here to understand is hospitals are very, 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 very resistant to opening firewalls at all. Anything, let's say you said, we're just going to put a small API, just a small query. No. So they're very hesitant in opening anything to their environments. So they prefer having pull method. They prefer that they contact whatever is needed. Now, if you know a little bit about the development space, this is something that you may see that there's at least one type of protocol that can do this, and that is Git. So Git is actually a surprisingly good tool for this type of one-to-many data exchange. And I know that you've used it for development. We use it for code, and we use in Trust over IP quite a bit. You can actually use it for data exchange as well. And in more particular, we're using in FEMS, we're using GitHub, because we use actually pull request system to do the kind of data exchange between project repositories and hospital repositories. And the part of the governance, part of the agreements also is that when you join it, you also get your own GitHub repository. So we have an enterprise account here being managed by the governance entity. And then the parties get their own repository organizational space, which provides also identity and access management for that repository. So we don't do much peer-to-peer direct contacts. We have a couple of instances where you can use and you should use, for example, re-authentication of the user, just directly hospital contacting the workspace or the data user. But mainly we use the Git protocol and a combination of GitHub, or you can exchange for any other type of Git service, which supports pull requests, and local Git service. And also you can see here on the shared services, you have the shared metadata catalog for the data discovery of the metadata of what is being provided, and a trust registry, which I'm going to come later on. Neil, I see your hand up. Go ahead.
Yeah, it's very interesting. It suggests you're basically putting in a query firewall. So yeah, you can hand us the query, but we're actually gonna run it. And if we don't like it, we'll do something, and then we'll put the results somewhere else. So it's basically putting a fire break in there, saying, okay, you can't run it directly. We don't want to put a hole in the firewall, but we'll hand you the results if you get, hand it to us. That's a nice solution.
Yeah, and actually, what I'm going to show next how it works. So you get a little bit more insight into that. So how it works on again, a very high level. So on the left side here, you can see the research team and the project management. So the step 0 is that when a researcher comes into a project workspace, they need to identify themselves. In Europe, we will have the EU digital identity, but this can be anything that can provide a sufficient level of assurance. It could be any kind of, let's say, level assurance high or substantial. We have decided exactly the requirements. But the key requirement is that you have the capability to assign and attach a digital signature that can be attached to the identification of your identity. So if you have, for example, in EUDI, you would have a personal identification data, but you also have a way to do qualified electronic signatures. And using this identity, you should be able to sign the decentralized identifier created by the workspace provider for you for this context. And in our use case, in our rulebook, we will define certain methods that can be used. We haven't defined them yet. We're mainly using in FEMS just did web for the easy part, but the design is that it doesn't really matter what you're using as long as it's being supported by others. So we're going to be limiting it to some of them. So when you have the DID here, you have the DID for the project as well as you will have the DID for the users. You're able to reference those DIDs in the Git repository. So whatever commits you do, if you do the data permits, instead of including any personal data, you can use the DID to reference that. And that is, again, just specific for this particular data ecosystem. So it's very limited as to what you can get out of that. So the first step of the data availability is that you use the project workspace to check which data controllers have the metadata that you're interested in. You build the cohort definition of what kind of cohort you want to use for your research. Then you run through the data feasibility query or availability queries. I'm not going to go deeper into that, but secondly, you want to go through the data permit application where you include the data queries and cohorts you want to do, and that is being run and verified in the Git repository, the pull request process being run with the hospitals that are included in that process, in the project. But thirdly, what you mentioned, Neil, is what we call in the federated data processing is what we call a federated node. So what is the federated node? It's essentially a container that picks up your code, what you want to run. It picks up from the Git pull request or the commit once the data controller receives it. It takes the code. It also takes in whatever you want to include in it. That what we define, for example, the data permits or any credentials, verifiable credentials, or the DIDs, etc. And it then uses the actual patient data, but the subset of what you're promised in this data permit to. So what is your cohort? That subset of the data that you're researching, it takes that from the hospital's database and then runs it in the federated node. So you have a very limited environment which has access to only that cohort data that you are interested in and you have the permit for. It runs the analytics query and the code that you provided it. And then lastly, it is being reviewed and results are released. We're still in the process of designing what all alternatives there are for the places where you're actually releasing the results to. But in general, yeah, that's you can do that automatically if your policies allow it, or you can manually review that, etc. So essentially, you're just taking the query, and after all the permit process, you're running it in the hospital's controlled environments. So you never actually have access to the data. You never actually have access to hospital environment. You just work with your tools in the workspace. So then the trust model, I want to hurrying up a little bit because this is the second to last slide, and I still want to have a few minutes of time for questions. So we have 4 layers where at least, let's say, the most important 3 bottom ones. So let's look at the bottom one. So the first layer is the ecosystem membership. So the trust into the ecosystem members, workspaces, data controllers is anchored by the governance entity. And the governance entity using the role-specific requirement, the role-specific agreements can define that, yeah, you have an active agreement, you are in the role of a workspace. Keep in mind that the data controller, a hospital, can also provide a workspace, so they can act in multiple roles as well. But that is an ecosystem trust registry. We haven't implemented a trust registry yet because we feel that there are actually some capabilities we may want to include in that, but we're implementing that at some point. But yeah, that's something that we recognize that's going to be an important part. Secondly is the digital identity or decentralized identifiers especially, which are then, as I mentioned, signed using the keys associated with your high-assurance identity scheme. And each user and each project will have their own decentralized identifier, and they're anchored by the workspace providers. And so, yeah, you can imagine that then the workspace provider has the workspace role, and they're anchoring the trust registry. Workspace anchor the identities of the projects and researchers, and they're verified then by the data controllers on the other side. Everything can be signed using the digital signatures, and we're still looking what are the optimal way of approaching this, but at least sort of the key things like the decentralized identifiers are signed using the digital signatures. We do use also verifiable credentials to do things like provide that the data controller, for example, provides a data permit credential, meaning that you don't need to carry the full permit around, but it's just they issue a data permit credential to state that we have given you a data permit. And other things are like a verified project, for example, a workspace will verify that this project is active and they have all the necessary contractual agreements and all the necessary verifications and identifications, authentications done, etc. So we're using also credentials here. And credentials are mainly being actually used within GitHub. So we add the credentials within the GitHub payloads. When you do the queries and federated nodes processing, we can have those credentials within that process and then verify them along the way. Also, something we are planning, haven't implemented or really designed deeply yet, is data policies, that the results could also include different kinds of policies that the data controller will license you with, that where they're allowing this data to be used. So that's also possible, but something we're still going to be researching a little bit later on. And lastly, I want to just mention a little bit about the business approach. That what this is for is that there's three primary things that the use cases we're doing here. One is that it's a benchmarking between hospitals, and that's already operative benchmarking. Clinical benchmarking is really important, and the same federated node model can be used for data exchange between hospitals as well for the benchmarking purposes. Commercial research for technology providers, biomedical companies, R&D organizations, what have you, and also non-commercial academic research for universities or healthcare providers who want to do that. And just what we aim to get here is that we get a lot of new treatment methods, we get quality of care increases, get just better quality and size of the data sets. All in all, start to get a lot more fast, frequent, better results, just accelerate learning, accelerate research. You can imagine if we can take this, what has so far taken even over a year to accomplish for our research, if we can take this down to months, just a couple of months for the whole process to be done, even shorter. I can see that is definitely happening once we mature. It's going to have a huge impact in general, just for the research community, and also pharmaceutical development and everything like this, and that has huge impact in this. Okay, that was my slides, and I would have one more slide somewhere, but I forgot to add it here. It was really about how we envision the growth to happen, because just the access to data, once that's been realized, we see that drives new interest from the market, from private sector parties, from universities, and just in general healthcare providers as well, which in turn will drive adoption and business interest from workspace providers. And that will obviously help us grow in numbers for both hospitals, for workspace providers, for data users. So it's really a perpetual growth cycle that feeds itself, with the benchmarking and research activities feeding it, data, access to data feeding that as well. And that was it. I think we're in time. That's very good.
Yes, excellent. Thank you, Antti, very much for this presentation. It's fantastic. We have 10 minutes for discussion and questions, if anyone would like to ask our speaker a question.
There was a question about the difference between layer 1, where you establish the ecosystem, and layer 2, where you talk about the identities, and how can you establish each? So the roles on layer 1 are generic. So you're just laying out the roles of potential members, and then in layer 2 is where the actual members sort of come on into the ecosystem.
No, actually, the way is that the layer one is based on the contractual agreements. So you would get a you would get a role essentially be added to the trust registry once you have an agreement in place, once you know sort of which roles you take in. That's the only thing it defines. You have an active role, you have active agreement, and you work in these roles. Then
Okay.
the actual data controllers here on the layer two, they're about that the operative identities, where you actually need to sign things, where you actually need to do things that on the operative, the transaction level.
Mhm.
So these are the differences of those.
Okay. Thank you. Did you, how did you find the rest of your partners when they were adopting some of these new, I mean, they're not so new anymore, but decentralized identifiers and verifiable credentials? Was everybody that you're working with pretty up to speed on all that? Or was
No,
this,
this is actually the identity. So the whole ecosystem so far is mainly centered around the eco ecosystem, and the technical and business partners came from in general from discussion that from what partnerships they had so far, the hospitals and universities. And the decentralized identifiers and identity part actually came from myself. So I've been part of the process from the very get-go, and started to bring in the idea that this needs to be decentralized. And also the who's the Helsinki University Hospital, the whole general vision of it was started from that this needs to be decentralized. We just don't know exactly how it's done. And their thought was that they didn't know how it's done. On conceptual level, they knew that we need these kind of layers of trust, but we don't know how it's done. So it was quite easy from that perspective to bring in the idea of decentralized identity and the governance models, and trust over IP has influenced that quite a bit. So yeah, but technically that's something that I've been bringing that and trying to help everybody understand how it works. And the decentralized identifier thing is something that is taking most of the difficult part. But to be honest, it helps that providers like Microsoft have Entra verified ID, which makes it actually a lot more robust thing and for them to trust, because they see that, okay, it's not a small player thing. It's not something, because they're very, very hesitant on taking on any kind of new, let's build this and design this from scratch things, understandably. So it really, really helps that there are big players that already have established solutions that provide decentralized identifiers and identities. So that has really been a key thing as well. Although Microsoft is not involved in as a partner anyway here, but yeah.
Neil.
Yeah, it strikes me that, we're talking about trust registries, where do they fit? And some of the models will say an ecosystem has a trust registry, and this would suggest you've got a whole series of different actors and players at different levels that all are going to need some sort of registry. You've got it down at the bottom, and now you've got digital identifiers, which are, I'm going to assume they're managed specifically for specific purposes that are assigned to people, and that may change over time. You probably need a registry of that. Services themselves, what services are as technology have permits to do they have a license that they are compatible, right? So what elements of this thing are and also information about the properties of the hospitals themselves in terms of what their capabilities are. Right. So if you're looking to understand the ecosystem, if registries are as, the qualified information about all the actors and the processes, then it suggests, I think it's a fabulous use case because it's already multi-ecosystem. It's in a heavily regulated area of sensitive data, and it works.
Yeah, I agree. And I just want to make one point here is that in our design, it's really imperative that we don't put things where they don't belong. For example, they did at the VDRs. They will be specific to whatever the project workspace wants to work with. The point is more that it needs to be resolvable by the hospital. So that's why we just need to define which methods are okay. But the anchoring of what the trust is there. We are not trusting exactly the VDR. We're trusting the identity that they use to authenticate themselves. And then it's up to the workspace provider really to make sure that whatever they're choosing the right one, because they're going to be liable for whatever happens if that's going to be hacked. So then the liability chain is going to be really, really important. So the responsibility goes here. So we didn't want to bring DID registries, for example, or VDRs into the hospital area because they don't care about that really. One thing as well is that where we use it also is that a DID document, we can expose an authentication endpoint toward the high assurance identity here, which means that the hospital, if they want to authenticate just one person from that team, they can make direct requests to the DID documents endpoint, which points to the workspace endpoint, and say that we want you to re-authenticate this person here. And then the connection between this identity wallet and the hospital is direct. So at that point, there's nobody in between because that is going to be performed using the protocols of the identity wallets then. So, but yeah, I agree that there's going to be there are registries, but we want to make sure that we minimize the need for excess registries as well. So the trust registry is something that we want to make sure that it's going to be multi-purpose in this. Go ahead, Carl.
Yeah, I was wondering, other than today's, we have a great recording of a presentation. Do you have more of the guts, the information about the guts? And is this project going to be publishing more information about how it has been built? Are there other organizations that are looking to copy this, mimic this, build from this, etc.?
Yeah, we do actually have we have one design document, or our ecosystem architecture document, which describes quite a bit, which is it's could be public. We just haven't published it, so it's a deliverable that we can make public, and I can share that to those who are interested. But also I do recommend, if you're interested more on the healthcare side and some of the backgrounds of the FEMS and the clinical parts, you can go to our YouTube page. And there's multiple meetups that we already have spoken about. I also there essentially running the same presentation as here, but we're going to be, I would assume we're going to be also doing a lot of more opening up of our design at some point. There's a huge amount of detail there, a huge amount of work that we've been doing. So we just want to make sure that once we publish something, we're going to be clear that this is not going to be changing too much. So yeah, we're going to do that at some point, but we're not just at the stage. But we're more than happy to talk the details. So I'm more than happy to go into any depth with in a more private forum, though.
Fantastic, thank you.
Antti, can you talk a little bit more about the accessing the data? So you say that the data never leaves the sort of the hospital environment, but do they, the people who are requesting or querying the data, do they get visibility to the data even before they run their algorithms?
So yeah, they do, but only from the perspective of metadata. And what it means in this case is that they understand, what they understand is that what are the, let's say, so OMOP is a common data model, which means that it doesn't define any characteristics of the information. It just defines a basic common model for structuring and defining the data. Then on top of that, there are vocabularies like ICD-10, for example, how you diagnose things, what are the treatments, etc., which are the vocabularies. And based on that information, each data controller will expose their metadata of what data they bring to the table. What they don't expose here is that what type of combinations are in the data. So they can say that, yeah, we have 1,500 records of, let's say, influenza treatments or whatever.
Mm-hmm.
But they don't say that you cannot find out whether those influenzas have been for children under 14 or over 16. They just know that there's 10,000 16-year-olds, but they don't know what the connections between the data is. So that's the only level of exposure that they will have. And but they also, Yeah, so essentially they know what they're dealing with. They know what the structure and the metadata is, but they just don't know the exact relationships of those data.
Right.
And yeah, so what they get from here is essentially aggregated results of the analytics processing. So
Right.
it doesn't even reveal any personal data afterwards. So it's
Right.
more or less just aggregated numbers.
And how do you, I mean, this is what we finished, we're at the top of the hour, so maybe I'll ask this question at another.
Yeah,
at
I can
another-
stay here for afterwards. So if you want to finish up with the meeting first.
Yeah,
I'm
so we
okay with staying.
call it the end of the recording and
Yep. Okay, so I will close up the meeting just by saying thank you very much for coming to speak with us. It's been fantastic. And I'm looking forward to releasing the recording of your talk also on our YouTube channel, which I think is great for outreach. And I'm going to turn off the recording right now and we can continue to speak. Thank you.